1, we will be solving for systems of equations and inequalities. So in section 7.1, we will be solving the system of equations by graphing. And there are three methods to solving systems of equations. First method is graphing, so that is your goal for today, to solve systems by graphing. So before we start solving the system, we got to figure out what the system of equation means. And what systems of equation is a set of two or more equations. So if I had an equation of y equals 2x minus 3, and if I had an equation of y equals x minus 1, these two equations together make a system of equations. So that's a system of equations, two or more equations together. Now, to solve the system, which means to find the solution, so to figure out what the solution of the system of linear equations is after you graph this, because we're going to be graphing, we're looking for the point of intersection. So where the two lines meet or cross. So we're looking for the point of intersection, and that is the solution of the system. So it's the point where they intersect, and we're looking for x comma y. At what x coordinate, y coordinate do these two lines intersect? So if I were to take these two lines, y equals 2x minus 3, and if I have y equals x minus 1, and if I were to solve the system, what we're going to do is graph these two lines and look for the point of intersection. So this is in the form of y equals mx plus b, y equals mx plus b, and if you notice, the slope is 2, which I can write it as 2 over 1 or negative 2 over negative 1. It still gives me positive 2. And the y-intercept is negative 3. And then for this line, slope is the number in front of the x, which is 1, in which I could write it as 1 over 1 or negative 1 over negative 1, because slope, remember, is rise over run. And the y-intercept, b, is negative 1. And to graph these lines, remember, you always start with the y-intercept. So I'm going to make my x and y axis, and I'm going to use the same graph to graph both lines, because we're looking for the point of intersection. So here's my y-axis, here's my x-axis. B, which is negative 3, which is my y-intercept, 1, 2, 3 at negative 3. We start at that point, and we're going to use our slope, which is rise over run. So this says up 2, right 1, down 2, left 1. So I'm going to go up 2, right 1, down 2, left 1, up 2, right 1, up 2, right 1. And I'm just going to draw my line through those points to create my line. And let's do the second one. Second one, we're going to start at negative 1. So when we start at negative 1, this one says up 1, right 1, down and left 1. So we're going to go up 1, right 1, up 1, right, up 1, right, up 1, right, and then down 1, left, down 1, left. So here's that line. And if you notice, these two lines intersect at that point, which is at 2, 1. Here's my x-axis. So the point is at 2, comma 1. And this right here is the solution of the system that's given. And that's what you're going to be doing today. I'm going to give you a set of equations, and you're going to graph those two equations on the same graph and look for the point of intersection to find the solution of the system. There's a couple other scenarios where you only have one solution, which is at the point of intersection. But if you have parallel lines, that means two lines with the same slope, different y-intercepts. These two lines will never intersect, So parallel lines would have no solution because there's no point of intersection, no solution. Now if I have the same lines, so if I have same slope, same y-intercept, if I drew one line and the other line goes right on top of it, that means they're the same line, so they intersect at every single point on the line. So I would say we would have infinitely many solutions. So to solve by graphing, you graph two lines and look for the point of intersection, and point of intersection is the solution of the system.